Hello friends, good afternoon. Welcome you all my YouTube channel Rao C Forum. Today we will start the important concept of strength of material. Friends, as you know, before starting a project or before starting to constructing a building or structure, firstly we have to know about the behavior of material. Friends, the two concept is the important in strength of material. First is the material is homogeneous and isotropic, and second one is we do not consider the weight of the material. The two parameter is stress and strain. These two parameters plays an important role in strength of material. Stress is nothing but it is the strength of material, and by definition stress is equal to force divided by cross sectional area. This is known as loads. What's known? Load either it will be tensile or it will be compressive. Means both type of load is known as axial load. Means axial load have two types, first tensile and second compressive. Friends, before constructing a structure we should know the behavior of material. Apart from that, how to determine strength, means we have to know the stress strain behavior of material. A mild steel is a general metal which is generally used in constructing material, or it is also known as structural steel. What's known as? It is known as structural steel. So in designing machine, a structure, truck, crane, then we should know about the strength of material. Strength of material. Strength is a term which denotes the resistance of material against deformation, against failure. So before going in deep in strength of material subject, we should know the stress strain curve. Friends, we should conduct a test on a material which is ductile or brittle. Brittle material is tested in compression test and ductile material is tested in tension test. So in mild steel we test static loading. We test for static loading, and next one dynamic loading. Dynamic loading. Static loading. Static loading means when we apply the load gradually, then it does not affect the properties of the material, and we applied the load rapidly impact, then it changes the behavior of material, properties of material. So we will perform a tensile test of a mild load under static loading, and that diagram is known as stress strain diagram. Then in stress strain diagram we should know the stress is denoted on y-axis and strain is denoted on x-axis. This is stress and this is strain. Friends, when we apply the load on a specimen using UTM using UTM. UTM is nothing but it the universal testing machine. Universal testing machine means why we call universal? Because it measure the tension, compression, torsion, bending, all the parameters. So we call it is universal testing machine. Universal. Okay friends. So when you apply the load on a material, this is tensile load, then the curve begins with the origin. It starts from origin O and move is a linear proportional. Proportional means when the two variables ratio are constant, then we can say that this has shows proportional behavior. O to A to B, when increase in stress, A to B is a slightly slope, not pure linear, it is slightly slope, and this is point B. This is point B. B to C, this is C, this is D, this is E, this is F, this is G. Friends, this is the original stress strain diagram of mild steel under static loading, not dynamic under static loading, because if we apply the dynamic loading, then behavior should be changed. So we applied gradual loading. Okay friends, so without wasting time, we will describe the one by one parameter which is the stress strain diagram describes. Okay, up to point A, the stress and strains remains constant. Means what will be the value of stress? The same value will be the strain. So up to point A, the value should be same. This point A is known as proportional point. Proportional points. And this is B, known as elastic point. Elastic point. C and D is known as yield point. What's known as yield point? C is known as upper yield point and D is known as lower yield point. Friends, when we increase the stress value at C, then C to D, it sudden drop the load bearing capacity, means it does not have the proper to load bearing capacity, and up to point E, D to E, it shows a permanent deformation without increasing stress. Friends, you should notice this point D, this is the stress should be constant. So up to point D to E, up to region D to E, the stress remains constant and deformation means strain vary. Okay, from point E to F, the material shows crystalline structure, means it's have some resistance ability to resist the stress. Okay friends, then E to F, it shows a crystalline behavior and its zone is known as strain hardening. What's known as strain hardening? Strain hardening. And this point F is the ultimate point. What's known as ultimate limit or ultimate point? This point F, and corresponding to the stress value, this is known as ultimate stress or ultimate strength. And beyond this, the material becomes softening, strain softening, and up to at point G, the material will be fell. Okay friends, you should notice the point O to A. The O to A slope remains constant. When slope remains constant, this is sigma, this is E. This is slope, means tan theta is equal to sigma divided by E. This is nothing but it is the modulus of elasticity. What's known as? It is modulus of elasticity. Means the ratio of stress to strain is the modulus of elasticity. Means higher the slope, higher the elasticity. Higher the slope, higher the elasticity. Means higher the value of E, which implies higher the elasticity. So the reason is, this is yield point D, this is ultimate point. F is ultimate point, this is fracture point. This is ultimate point, and this is fracture point. This is fracture point. Friends, I will show you the reason which is shown by the stress strain diagram. Friends, this reason or this line shows the linear reason. What is shown? Linear elastic. From A to B, this shows this region non-elastic. This shows non-linear elastic region, and C to D, this is the yielding point, this is the yield region, and D to E, this is the perfectly plastic region. What is known as? This is known as perfectly plastic region, and E to F is the strain hardening, and F to G is the strain softening point. Okay friends, this is stress, this is strain. I will tell you in previous video, I have told that the brittle material and ductile material. In brittle material, it have the strong strength in compression zone and moderate in shear but weak in tension. But in ductile material, it is strong in tension and weak in shear and moderate in compression. So friends, in design point of view, we will consider the lower yield point. This yield point is the corresponding to this points the stress known as yield stress, Fy. Fy is the yield stress, and the value of Fy for the mild steel is 250 MPa, and this to this is known as this is 0.2%, 0.002 up to 0.00. It shows the yielding point. This points. Okay, this point at point C, it shows yielding point at 0.2%. Okay friends, in design point of view, actually we will see it is a conventional curve. It is a conventional stress strain diagram, but in actual, when you apply the load up to E to F, then it shows this like, this is a G and this is a G. Its curve O, A, B, C, D, E and G. This is a true curve, true diagram, and O, A, B, C, D, E, F, G is a conventional diagram. So in engineering behavior, for the actual information of the material, we will consider the conventional behavior of the stress strain diagram. So friends, I hope you enjoyed this session. Thank you.